Assalamualaikum sir, I am Yan Ahmed, Reg 20180889, and we are using Pick and Place Robotic Arm as our CP for this course. First, we will have small intro of what robotic arms are and why they are used. Robotic arms are basically mechanical devices used for ease of human being. They are used to move objects from one place to another. They are even used to move heavy machineries, and they are also used in laboratories for scientific work. Now, coming towards working of robotic arm, we have a robotic arm having with different links joining together, moving in different directions by servo motors attached at different joints. These servos are being controlled by Arduino, further by Blink app through our Bluetooth module HC05. By this, we can give any movement to our arm through our smartphones. Thank you.
Now we will do some necessary analytical calculation. In analytical calculation, we will find degree of freedom, gripping force, torque and power. We will use Euler equation to find the degree of freedom, and we have found that degree of freedom is equal to the 6. So the calculation of degree of freedom is necessary as it tells that how much equations are needed uh, for velocity and acceleration analysis. And likewise, we will find the gripping force by using the following relationship. Uh, Gripping force is necessary. Gripping force tells us that how much force is required to hold the object of certain weight. Like in our case, the object weight is 5 kg. So we need at least 8.33 Newton force to hold the object and to shift it from one platform to the other platform. Now we will find the torque and power. In this case, we are assuming a worst case scenario. We are assuming that all the links are horizontal to each other. So in this case, moment arm is largest. So there are two types of torques. One is static torque and the other one is dynamic torque. Static torque is due to the weight and the dynamic torque is due to the inertia. So we will find static torque by using the following relationship, and we will find dynamic torque by using the following relationship. So the total torque will be the sum of static torque and the dynamic torque. And in the end, we will find the power using the following relationship. Thank you. Now we will discuss a designing of simple pick and place robotic arm on MSc Adams. So first of all, we will create a new model with a model name of robotic arm design and the gravity pointing in the negative global y direction. Now we will add three objects. One of them is cylindrical base and two are links of the dimension as shown in figure. Now we will add two gripping links as you can see in this figure. We will add one more link using add to part option and weld it with the third link. Now we will make some sort of connection between these links. So for making connection, we will go to the connectors option and click on the revolute joint and add revolute joint at this point, at this, at this, at this, and the last one will be at the base, so that the base can rotate about its own axis for picking and placing operation. Now the next step is to give the gripping link a shape of mechanical claw as shown in figure. Now we will make a platform 1 by using box option at a certain distance of the dimension 400 by 80. We will fix the platform 1 with respect to the ground by clicking on the lock option in the connectors menu. We will repeat the same procedure for the platform 2 as shown in figure. Now we will add a object by using box option of 40 by 40 dimension on the platform 1. Now we will make contact of box with the platform 1 by making box I object and platform 1 J object. We will repeat the same procedure for all other contacts. We will make contact of box with the left hand, right hand, platform 1 and platform 2. Now in the next step we will couple the joint 1 with the joint 2 with joint 1 as a driver and joint 2 as a driven. Now we will assign a stiffness coefficient equal to 10 and damping coefficient equal to 5. Now we will insert or write a function as you can see in this figure by clicking on S force-1. Now in the next step we will add motions to each of these joints and write a function as shown in the slide. We will write all these functions for each one of the joint. Now I have added two more boxes as shown in figure for my convenience. Now lastly I have added two servos motors at two of these joints to conclude my design. Now you can see the simulation of the robotic arm, and you can see here that the simulations are working quite well. Thank you. Now we will discuss results obtained from MSc Adam simulation. Now in the information tab you can see that there are 7 degrees of freedom, but the calculated degree of freedom was 6. That one extra degree of freedom is due to the translational motion of two boxes that I have added at the end, but it is not the part of robotic arm. So the degree of freedom in our case is 6. Now I have plotted the graphs of gripping force, and I have found that the average value of gripping force is 280 Newton, which is much greater than the calculated value of 8.33 Newton. So it shows that the gripping force is more than enough for holding and shifting the object from one platform to the other platform. That much high value of gripping force is due to the spring that we have used is of really high stiffness. And the zigzag portion you can see here in the graph is due to the vibration of the arm due to the presence of motors and object handling. Now I have plotted graphs of torque for each joint, and I have found that the joint below the lower link has the maximum torque because it has the largest moment arm, and for the joint below the third link has the minimum torque because it has the lowest moment arm. So we must choose a motor that can supply torques much greater than 100 Newton meter in order to pick and place the 5 kg object adequately. Now we will discuss forward kinematics. In forward kinematics, we will discuss position, angular velocity, and angular acceleration of each of the link. I have plotted the graphs for each of the link as you can see in the slide below. And I have concluded that the maximum angular velocity and the maximum angular acceleration for the third link is 280 degree per second and 270 degree per second square respectively, and the minimum angular velocity and the minimum angular acceleration is at the lower link attached to the base. And the response of the angular acceleration has very sharp peaks. It is because of the vibration due to the motors and handling of the objects. These vibrations can be reduced further by increasing the damping. Thank you.
Now coming towards the fabrication part, sir, as you know, it's very difficult to build model physical in current situation. Hence, we are just done theoretical part. So first, we have different components being used to make robotic arm. They include servo motors, controllers, mechanical claw, bearings, and power adapter, and the most important X305, the Bluetooth module. Then we have Arduino circuit diagram along with servos and Bluetooth module attached to it. In the end, we have done the cost analysis part, and the grand total comes out to be 5,700 rupees, and it's very reasonable cost to build robotic arm. This is all from us. Thanks a lot, sir.